Hello and welcome to UWE and this talk about automotive engineering. My name is Dr. Benjamin Drew and I'm the program leader for automotive engineering. So welcome everybody to this talk about automotive engineering. I shall run through this talk, and then at the end of this session there should be a Q&A where you can ask me any questions if you have any. So I thought I'd start by talking about what is automotive engineering. Okay, now automotive engineering is essentially mechanical engineering, but focused around automotive applications, because the principles are very much the same, but we want to focus very much around the way that mechanical engineering fundamentals can be applied to the automotive world and the automotive industry. So I've got some examples of what is automotive engineering. So this first picture shows some computational fluid dynamics work done on a cylinder inside an engine, looking at the flow directions, flow speeds of the gases inside a cylinder. We've got a picture here of what's known as platooning, where you have connected autonomous vehicles that form a sort of group or a train of cars on a motorway to increase efficiency. This is a picture of a car inside a wind tunnel with some flow visualization, looking at how the flow flows over the car, and clearly aerodynamics is an important aspect of automotive technology, because the lower the drag, the more fuel efficient or the more efficient the vehicle is. We've got a picture here of a car on a rolling road. And rolling roads are used for all sorts of different things, but this looks like it's looking at emissions. There's some boxes on the back of the car that are measuring the fuel or the emissions of the vehicle, and that's obviously very important at this point, with lots of regulations around driving emissions and different test cycles being undertaken in the lab, and the variability between those results and the results you actually get on the real world. This is a picture or a CAD drawing of a double wishbone suspension system for the front of a vehicle, and part of vehicle development involves vehicle dynamics, looking at different types of suspension, and the kinematics, which is how the links move and the impact that has on vehicle ride and handling, and obviously that's also a big area of research and development in the automotive industry, so we learn about vehicle dynamics. We've got a picture here of automotive manufacturing. Again, this is very important in terms of the automotive industry, and one of the interesting things about automotive manufacturing is it is sort of pushing the boundaries of what's possible in terms of mass manufacture, with cars moving sort of away from the sort of standard steel production to using sort of mixed metals and even composites as components of vehicle bodies. So that's important. And then, with the move away from internal combustion engines or traditional sort of non-hybrid vehicles to sort of more electrified powertrains, that's an area of intense research in terms of automotive technology, emerging technologies, and so obviously that looking at the sustainable transport of the future is very important. So what we learn about in this program, well, like I said, the program is essentially based on mechanical engineering, but with automotive specific topics. So year 1 and year 2 are actually common with mechanical engineering, and then obviously you specialise in year 3 and year 4. And so there's these sort of fundamental engineering science topics of stress, dynamics and control, manufacturing, mathematics and thermofluids that sort of thread throughout the program. Okay, in all 4 years there'll be a topic around one of these things. Okay, and you'll be covering all these sort of fundamental principles. Okay, now alongside that we've got some automotive specific modules. Like I said, in the first 2 years, although the main content will be with mechanical engineering, a lot of the tutorials and various other aspects of the module will be automotive, will be tailored to automotive applications. And then in year 3 and year 4 there are specific modules for automotive engineering students around vehicle dynamics, around engines and emerging automotive technology and vehicle manufacturing. Okay, and they are sort of like I said, they are entirely automotive focused for the automotive engineering students. Now, we've also design as a big fundamental feature of any engineering program, and that's no different here. Again, design thread throughout the program in all the years, with year 1 and year 2 sort of focusing on design principles and how to actually do engineering design, and then in year 3 and year 4 there are sort of specific project modules where you're given a project brief, and a part of the solution to that brief will be around design of a product or a system. Okay, and the other aspect that's important for graduate engineers is to have the required level of professional skills that engineers require upon graduation to effectively work in industry. And again, this is a sort of I guess a relatively new feature of this program, in the sense that is also thread throughout every year at university. Starting in level 1, we have an engineering practice module that very much focuses on helping to develop some of those professional skills that are required, things like teamwork, communication, and various other aspects of that are required of a professional engineer in industry. In our engineering curriculum, we are introducing a broad range of competencies and social responsibilities required in order to be a professional engineer in the workplace. This means we are teaching engineering habits of mind through the engineering design process, so that our engineers leave ready to get a job and contribute to society and industry. Industrially placed projects and problems are at the heart of the curriculum. All our students take part in group project weeks where we aim to make a difference. In year 1, we work on globally focused engineering without borders challenges, and in year 2, we work on community focused regional challenges. Central to this is an understanding of the importance of diversity in engineering, making the economic business case for diversity, as well as the democratic and equitable underpinnings of engineering design. And as a framework for this, we use the Sustainable Development Goals that have been developed by the United Nations. This is a new engineering building that's just been opened at UWE, and it's a state-of-the-art multi-million-pound building that's purely for basically the engineering programs at UWE. Okay, it's based around 4 floors. The upper 2 floors are sort of offices and classrooms. We use a number of state-of-the-art learning, technology-enhanced active learning spaces. But then the lower 2 floors are focused around some of the lab areas, and obviously there's all the sort of standard lab spaces for dynamics and thermofluids, and we've got a big machine shop and some prototyping areas. But there are some specific automotive testing facilities that we have as well. We have 2 double engine test cells, so that's two cells each with 2 engines inside. And at the moment we have a spark ignition, so that's a petrol engine, compression ignition, which is essentially a diesel type engine, and they are running engine dynamometers. And then we've got another space for sort of emerging propulsion technologies, where we can install things like electric drives and hybrid propulsion systems. We also have a rolling road, which is essentially a full vehicle chassis dynamometer. So instead of it just being an engine, we can actually drive a car and put that on the rolling road. And we also have a driving simulator with full motion and a virtual reality as well, which is available to be used by the students as part of the engineering programs. And each of these spaces is accompanied by a classroom, because part of the approach that we have taken with engineering is it very much an integrated approach with the practical work and the theoretical work running sort of concurrently and alongside and supporting each other. Now, you're probably aware that we offer both a Bachelors of Engineering or a Masters of Engineering, and you might be wondering what the difference is. Well, basically, the Bachelors of Engineering is a 3-year program. That's one of the big differences, as opposed to a 4-year program for the Masters. But the sort of other big thing that happens after you've done an engineering degree is you might want to become a chartered engineer. And to do that, you need to sort of sign up with the Institution of Mechanical Engineers, and to become chartered, you actually need to demonstrate at master's level knowledge. Okay, and the easiest way to do that is with an integrated master's level degree, which is an undergraduate program but gives you
a master's level qualification. If you do the Bachelor of Engineers, you can still become an incorporated engineer, but to upgrade to chartered, like I said, you'll need to demonstrate some sort of master's level knowledge. That could be through doing an MSc, either with us or with another institution, or like I said, you do the integrated master's program with us, and you leave with the necessary academic or educational knowledge to become a chartered engineer. Now, the progression onto the Masters of Engineering program actually is dependent upon the performance in year 2. So even if you came in on a BEng, and if you do well at year 2, you'll be offered the opportunity to change to the MEng program if you want to. So it doesn't really matter, and that's the same even if you come in on the MEng program. It is still dependent upon the year 2 marks. The criteria that you need to meet is 60% across level 2 modules or year 2 modules. Okay. Tariffs for entry for the MEng, we ask for 120 tariff points and at least grade C and A level mathematics, okay, plus a science, sort of typically physics, but it can be any science. For the Bachelors of Engineering, it's slightly less, it's 112 tariff points, but we require grade C and A level mathematics, and again we want at least one science. The other thing we offer is certainly is a placement year, typically between years 2 and 3. Okay, and one of the big benefits of doing a placement is it gives you some real experience of engineering industry. Okay, and because of that additional experience, when you do a placement, not only do you come back to the university for year 3 and year 4 to complete your studies with a sort of new insight and appreciation of what you're doing and why you're doing it, but also you're more likely to graduate with a better degree, and clearly some experience is very beneficial when you're applying for jobs upon graduation. The fact that you've actually experienced parts of working in an engineering industry is clearly a great benefit. So your application gets sifted towards the top because of that additional experience. Okay, it gives you a big opportunity to develop your professional skills and obviously gain some industry knowledge and network. Often students that have done placement actually come back to university with support from the company that they're working for. So sometimes companies will sponsor you to continue your studies. Sometimes jobs are based upon placement performance, so obviously like the placement could be considered to be like a year-long interview process, and often students come back with job offers ready for when they do graduate. And we've even had students that have gone on placement and they've actually decided to come back sort of part-time while continuing their employment with their company. So obviously these are some of the benefits of actually going on placement, is it really sort of helps that transition from university to the work environment. Now we do support the process from the university, but it's very much down to the students to arrange their own placement with our companies. Obviously we've got contacts with many companies. These are just some of the examples. Ricardo's a big engineering consultancy that does a lot of automotive applications. BMW we're all familiar with, and obviously their focus in this country is engine manufacturing and the vehicle assembly in Oxford. Millbrook is a big testing facility in Bedfordshire. They do an awful lot of automotive testing and certification. JCB, again, we're all familiar with JCB, who make many sort of diggers and other industrial equipment. And AP Racing is a small company, but they make brakes, performance brakes, and they also do some component assembly for other manufacturers as well. We've had students go on placement with all of these companies. In terms of teaching and learning, like I said, we've got this new building, and it embeds very much sort of technology-enhanced learning in all the learning spaces, and this enables some innovative teaching approaches, evidence-based approaches that allows you to reach your full potential. So it's not just based around traditional lectures with smaller group tutorials. We very much sort of focus very much on active learning methods. that actually means you leave the facilitated contact time actually having learnt and practiced things. So in terms of some of the features, lecture capture is very much a sort of very much a thing that we all do. So it means that if you can watch back the lecture that you may have been to in your own time, obviously to review what you've been covering. You could make obviously notes, and clearly if you've missed a session for whatever reason, you're not put at a disadvantage. You can actually go and watch the lecture again. Well, we use polling software throughout, so again, this is a way where you can actually you can ask questions in the lecture or in the teaching session, and students can respond using their an app on their mobile phones. And it's a way of sort of getting some interaction going on and some discourse, and allows you to sort of determine or measure your level of understanding, so you know if there's areas that you need to revise or work up on. But it's a great way of sort of testing yourself throughout the program. We also do quite a lot of flipped delivery. This is something I've focused on personally, where instead of students coming to a lecture and then learning about stuff or being delivered content and then working on mastering that content in their own time, we actually deliver the content before the contact time, and then that contact time is then used more effectively to actually master the content in that facilitated environment. Okay, so you read and watch videos on the course material in your own time, and then you come to the classroom and you actually we work on applying that knowledge as opposed to focusing on delivering knowledge there. And we're also one of the sort of leading universities in terms of online e-assessment. We have a UE builds system where that runs e-assessments, and it's very smart in the sense that we can ask all sorts of different questions with randomized parameters, and it can provide tailored feedback depending on your answers, as well as quickly giving you the marks that you got in that assessment. We use it for formative assessment as well as summative assessments as well. So assessments that are there to give you more information, and those that actually contribute to a module mark, which then feed into your degree. Okay. Now, our aim as a department and as a program is to develop professional engineers, ready and able graduates. And like I said, we actually embed this from the first year. Okay. The other thing that sort of feeds into that is that we're actually introducing students to industry standard software from early on. So we obviously computer-aided design is one of the sort of key features, and we use SolidWorks for that. Some of you may be aware of SolidWorks, and that's industry standard. Modelling and simulation features throughout the program as well, and for that we use a piece of software called MATLAB. Finite element analysis and computational fluid dynamics, they both use a piece of software called ANSYS. And we also, for automotive engineering, we actually do some engine simulation work, and that's using a piece of software called Wave, made by Ricardo, which is that company that I mentioned earlier on the placement slide. Now, all of these packages are actually available for free to download, or within the department available 24/7, 365 days a year. So the students can actually install a lot of this software on their own computers if they've got one. And like I said, if they don't have a computer that they have available to them, they can actually come on campus whenever they want to use this software, because it's all on all the engineering computer labs. Now, finally, projects. In year 3 and year 4, we have a number of different projects or modules that are core to the programs. Okay, in year 3, you do an individual project, which is a sort of substantial piece of individual research, and then we've got 2 group projects. One in year 3, which is the group design and integration project, solving sort of multidisciplinary teamwork project where you work with other engineers in different sort of engineering disciplines, so things like electronic engineering and mechanical engineering, to solve a specific sort of project brief, authentic real-world problem in a sense. And then if you're doing the master's year, then we have this large capstone project, which is also a group project in year 4, which is again around an authentic project, real world problem, where you're given a design sort of brief or a customer requirement, and then you work in teams to solve, produce an engineering solution to this to the brief, but that also while appreciating also the commercial side of things, the business aspects as well. So if you're developing a product, it's also about how do you bring that product to market, at what cost, and so on and so forth. So there's a lot of areas as well of the sort of engineering industry appreciation, as well as not only the sort of technical solutions. And these are fantastic sort of opportunities for you to showcase your skills in an area of your choice. So and so often what happens is sort of at interviews, they might ask you about some project work or some team activities and things like that. And obviously these are act as like a portfolio that you can really talk about, where you've gone into some real depth in terms of a project that you've been working both individually and as a team, which is clearly sort of close to how engineering industry works. It's very much a sort of team-based industry. So clearly, as part of these projects, you may involve some empirical work or some experimentation, and all the facilities within the department and indeed the university are available for your use during this time. Now, obviously, university is also about the things that you do outside of your sort of academic time, and there's clearly a number of clubs and societies operated by the Students' Union and the university. But of particular interest to automotive engineering is formed a student. It's basically the IMechE organises this competition, which is actually a global competition, and it's the sort of aim is to design, manufacture, and compete in a single seat racing car. So the students have a team, and the work during the year is to design and build this vehicle, which then you take to a competition, generally held in the summer, where you actually compete in the car. Now it's a real sort of USP in a sense of this program, because of the nature and the way that we actually run this thing. Any students can join. Okay, they can join the team, and you become part of this sort of team working on the vehicle. And it's a real, like I said, it's a real engineering sort of problems to solve, a real sort of teamwork approach as well. And again, it's a real showcase of your skills and abilities to work in sort of, okay, it's not quite industry, but it's still very much a real engineering exercise. We're building a real car to compete against other universities, and we're pretty successful as well in terms of the recent results. So in 2019, which is the last time the competition was run, we had obviously COVID-19 was a big issue in 2020. But we came 8th overall at Formula Student UK, which is the competition that was held here in the UK. And out of all the UK teams that attended, we were 5th. Okay, and then we also took the same car over to the Netherlands for the Formula Student in the Netherlands. We came in as an international team, and we came 7th overall in that competition, and we were 2nd out of all the UK teams that entered into that competition. So, clearly, we're gaining a pretty good reputation of producing winning cars. Now, clearly, at the end of your program, you'll be looking for an engineering job, and these are some of the sort of, I guess, more well-known companies where automotive graduates have gone to. So, clearly, there's some big names here: some Aston Martin Racing, BMW, Jaguar Land Rover. There's a big name: JCB, Bentley, Ricardo, as I mentioned earlier. Williams Racing. We've had students that enter the sort of F1 industry. Multimatic and Denso are some other big names in the automotive industry, as is Gibson Technology. So these are just some of the big names where students have gone to. And with the big companies like Jaguar Land Rover and BMW, you actually enter onto their sort of graduate training schemes, where you get to experience a number of different areas of the company before sort of deciding to settle somewhere specifically and focusing on a particular aspect. So that could be manufacturing, that could be research and development, It could be chassis, all sorts of different areas. And so, like I said, Jaguar, Land Rover, and BMW certainly operate, and Bentley operate those sort of schemes where you get a 2-year tryout in a number of different areas before settling on a specific area. So that's, like I said, they're just a number of some of the larger companies. Clearly, there's also a number of other companies that aren't listed here that are, perhaps a bit smaller, but it gives you plenty of opportunity to enter the automotive industry if that's what you like. Some sort of highlights about UWE Bristol as a university. We are rated TEF Gold. TEF stands for Teaching Excellence Framework, and Gold is the highest rating. So in terms of the quality of the teaching, we're in that top bracket for that. Okay. The university as a whole is 21st in the UK according to the Guardian University Guide, the most recent one. And if you actually look up mechanical engineering, or which is what this program is based around, that's actually 13th in the country. So we're right at almost reaching the top 10 for mechanical engineering in the United Kingdom. In terms of graduate employability, we're also in the top 20 across the UK. 92% of graduates are, and this is, like I said, university wide. 92% graduates are in work or professional work or further study within 15 months of graduation. Okay, and if you look at automotive engineering, where 100% of automotive engineering students are in further work or are in professional work or further study. I think within 6 months of graduation. So we have this very, very you come to university come to UWE to do a automotive engineering degree, and you will basically we can almost guarantee you getting a job at the end of it in professional engineering. And in terms of student satisfaction, we're very proud that we're second in England for student satisfaction, according to the most recent national student survey. So students come to the university for a great student experience, and we provide that to them. So talking about student experience, we've got excellent links to the city, connections to every part of the university. It's a popular base. Bristol is very popular for big multinational companies like Rolls-Royce and Airbus, and Intel. They're sort of virtually next door, these large companies. And so there's employment possibilities right on the doorstep for our students. Bristol is one of our USPs as well, and it's recently been voted one of the best places to live in the United Kingdom by the Sunday Times. Students feel very much part of the community at French A. We're a campus university, and we have a lot of facilities are based around our campus, and students can access them 24/7. So throughout the year. So it's very much, like I said, it's got very much a community atmosphere, with people being on campus. And clearly the new engineering building is an example of this major investment into new study spaces and facilities. That's across all our campuses that students can book or just turn up to use. So thank you very much for listening. Please enjoy the rest of your day, and take the opportunity to have a look at some of the other talks that are going on. There's going to be a Q&A session following this talk. And if you think of any more questions or anything else, then please get in touch. There's my email address, benjamin.drew@ue.ac.uk. I'll be more than happy to answer any questions you may have. And there's a microsite for the open day, which, like I said, I encourage you to explore. And clearly, if you visit our website, there's more information about the course as well. So thank you very much for your attention, and goodbye.